let's go over the in-person gateway from yesterday. So 2 over x squared. Common mistake here is people will put that this is like ln of absolute value of x squared, or like 2 times that or something like that. This is not the right antiderivative, because the derivative of ln of x squared is 1 over x squared times the derivative of x squared, which is 2x. And so this is not equal to 1 over x squared, it's equal to like 2 over x. So you're getting the wrong derivative. What you have to do instead is you have to remember that 1 over x squared is the same as x to the negative 2. So this is 2x to the negative 2. So this antiderivative, we can do an anti-power rule on this. So x to the negative 2, increase that by 1, we get negative 1, and divide by negative 1, that's the same as multiplying by negative 1, so this becomes a negative 2. And you can check that this derivative, if you do the derivative of this, you would get negative 1 times negative 2 is positive 2, times x to the, drop this by 1, negative 2. Okay. And then the negative 3 sine of 2x, the derivative of cosine is negative sine. So the antiderivative of sine is negative cosine. We keep this a 2x. Oh, also, should be change this sign, make that positive, because the derivative of cosine is negative sine. And then instead of like multiplying by 2 at the end, like you would when you're doing a derivative of cosine of 2x, you would divide by 2. So this becomes 3/2 cosine of 2x. And then this is an indefinite integral, so we put a plus c at the end. All right, next one. Integral of 5, or antiderivative of 5, is just 5x. Antiderivative of e to the 2x is just e to the 2x divided by 2 instead of multiplied by 2. And then this is 1 over x to the 1/2, or x to the negative 1/2. So bump the power up by 1, so negative 1/2 plus 1 is equal to positive 1/2, and then divide by that power, which is dividing by 1/2 is the same as multiplying by 2, so we get 2x to the 1/2, or 2 squared of x. And then indefinite integral, so we do a plus c at the end. All right, cosine of x over 3, we integrate that, we would get sine of x over 3. If we did a derivative of sine of x over 3, we would pull out like a 1/3. If we're doing an antiderivative of cosine of x over 3, instead of dividing by 3, we're going to multiply by 3. So we really just like do the opposite. And so now we can check that this is the right antiderivative by doing the derivative. Derivative of sine of x over 3 is cosine of x over 3 times a third. And so the 1/3 would cancel out this 3, so that gives us the right antiderivative. And then the integral of 2x is just x squared. And this is a definite integral from 0 to 6 pi, so we just put those bounds in. So we get 3 sine of 6 pi over 3, so that's 2 pi. And then plus 6 pi squared. And then minus, and we need this all in parentheses. It's actually not going to matter here, but we would get 3 sine of 0 plus 0 squared. This is all going to end up equaling 0. That's why it doesn't really matter so much in this case, because adding or subtracting 0 doesn't change the answer. But in general, you need these parentheses around it so that you're subtracting all of the terms, not just the first term. All right, x squared e to the x cubed. When you integrate this, you can't just like integrate. So this is like a product of things. So you can't just like integrate like each piece at a time and then just multiply the answers. It doesn't work like that. You won't get the right antiderivative. You have to do a u substitution here. So our u substitution, you look for a good choice of an inside variable. Good choice of an inside variable here would be x cubed, and then du is the derivative of x cubed, which is 3x squared, and then by the chain rule times the derivative of x, which is just dx. Okay, so x squared e to the x cubed dx. So we can replace x squared dx with, well, we can almost replace it with du, but there's this annoying 3 right here, and so how do we deal with that 3? Well, we just divide by 3 on both sides. So 1/3 du is equal to x squared dx. And so now we can replace this x squared dx with 1/3 du. And we can replace e to the x cubed with e to the u. So our integral becomes e to the u times 1/3 du, and I'll put that 1/3 in front. And then the antiderivative of 1/3 e to the u is just 1/3 e to the u. This is an indefinite integral, so we do a plus c. And then we will do e to the x cubed plus c, so we just replace that u back in terms of x, and then this will be our final answer. And then you could check that this is the right antiderivative by just taking the derivative of this. So derivative of 1/3 e to the x cubed is just 1/3 e to the x cubed times the derivative of x cubed, which is 3x squared. And so the 3's cancel out, and then you have x squared e to the x cubed, which is what we wanted. All right, it's getting a little messy here. So cosine to the 4th x times sine of x. So again, we're going to have to do a u sub here. So let's choose u to be cosine of x, and du would be the derivative of cosine, which is negative sine of x, times the derivative of x, which is dx. Okay. So this becomes u to the 4th, and then sine of x dx is almost equal to du, but again we have this like annoying like negative in front, and so we have to bring the negative to the other side, so just multiply by negative on each side. So negative du is equal to sine of x dx, so we can replace this with negative du. So our integral becomes the integral of negative u to the 4th du. And we integrate this, do an anti-power rule on that, raise the power by 1 and divide by that exponent. Keep that negative there as well, just carry it along. And then plus c, because this is an indefinite integral. And then we just sub back in for x. So u is equal to cosine x, so this is cosine to the 5th x plus c. Let's do black because there's too much stuff going on here. I spaced out the gateways on the in the math center a little bit better. It's actually double-sided, so hopefully that'll be a little better. All right, 1 to 2 of ln of x over x. So here you're going to want to do a u sub if possible. So whenever you can look for a u sub, so always look for a u sub when you're doing these. If you can't do a u sub, you're going to have to do integration by parts, but always make integration by parts like your last resort, like that's your last option. So if you can do a u sub, do a u sub. And so in this, if we do u is equal to ln of x, then our du is equal to the derivative of ln of x, which is 1 over x, times derivative of x, which is dx. And so that conveniently shows up right here, 1 over x dx. So we just replace that with our du. And so our integral becomes the integral from, well, let's wait on the bounds for a second. So we just have a u on top, and then x dx just gets replaced with du. And what are our bounds? I want to put my bounds in terms of u because I kind of like doing that. Well, if x is equal to 1, then u is equal to ln of 1. Ln of 1 happens to be equal to 0, so I'm just going to put a 0 on the bottom. And then at the top, if x is equal to 2, then u is equal to ln of 2. So ln of 2 up here. Oops. All right, now we integrate this. This is like u to the 1st. So again, we have to do like an anti-power rule on this. So this becomes like u squared divided by 2, right? Raise that exponent by 1 and then divide by what we get. So this is 1/2 u squared from 0 to ln of 2. These bounds are actually in terms of u, so we can just plug them in. So we get 1/2 ln of 2 squared minus 1/2 of 0 squared. So that's our final answer. Get rid of that for space. All right, x e to the 6x. So we can't do a u sub here. If we made our u be like 6x or something like that, then our du would just be 6dx. And then, well, this, we could replace this x with like 1/6 u, but then that wouldn't really make the problem any easier to integrate or something. So this isn't going to end up working. So we're basically forced to do an integration by parts here. So we have to pick a u, and we have to pick a dv. E to the 6x is a good choice of dv, because when we integrate that, we get something that is basically just as easy to integrate as e to the 6x is. And x is a good choice of u, because when we take that derivative, we just get something easier to integrate. So the integral of, the derivative of u du is equal to the derivative of x, which is just 1 dx. And the antiderivative of e to the 6x is just e to the 6x divided by 6. So 1/6 e to the 6x. There should be a du here, not too important. All right, and so our integral becomes uv minus the integral of v du, because this is the integration by parts formula, which you should know. So uv becomes 1/6 x e to the 6x. I'm just kind of rewriting this to put all the constants in front, and then like e's and stuff like that all the way to the right. It's just kind of standard notation. And then minus the integral of v du, which is 1/6 e to the 6x dx. So the integral of 1/6 e to the 6x. So that antiderivative is just e to the 6x divided by 6. So this is like 1/6 times 1/6. So 1/6 times 6 is 36. And this is an indefinite integral, so we do plus c at the end. All right, last one, do it in red. All right, with this one's really similar to like this one back here, but it turns out that it's not going to work if you try to do a u sub, because if you did u equals ln of x, then your du would be 1/x, and you have an 1/x cubed here, so you can't do like du cubed or something like that. Like that's just not gonna work. So can't do u sub. Have to do integration by parts. So u and dv, we got to make choices for those. Can't pick dv to be ln of x. This is not going to work because we don't know how to integrate ln of x without just doing integration by parts again. So we have to make our u be ln of x, and our dv will be 1/x cubed. 1/x cubed, you always want to, when you're integrating that, you always want to think of this as x to the -3. And so now we figure out what our du and our v are by taking a derivative of ln of x and then integrating x to the -3. So derivative of ln of x is 1/x dx. And the integral, put a dx over there, I always forget that. Integral of x to the -3 is bump the power up by 1 and divide by that exponent, so 1/-2. All right, so our integral is uv minus integral of v du again. uv is -1/2 x to the -2 times ln of x. Okay, and then minus the integral of v du. So minus -1/2 x to the -2 times du, which is 1/x dx. So this equals 1/2 x to the -2 ln of x. I'm going to make this plus because the negatives cancel. Plus 1/2, and then this becomes x to the -3. It's x to the -3 because this is x to the -2 and this is x to the -1. So this is like, so x to the -2 times x to the -1 combines to x to the -3. So this becomes -1/2 x to the -2 ln of x plus, well, I think it's going to end up being minus at the end. So increase the power by 1, so we get -2, and then divide by -2. So 1/2 times like 1/2 is 1/-4, so we get -1/4 x to the -2. And then we're doing this as a definite integral from 1 to 3, so let's do that. So we plug in 3. By the way, 7. If we have just like x to the -2, that's the same as like 1/x squared, so I'm going to write this as that. All right, so now if I plug in 3, I get 2 times 3 squared, which is 9. So 2 times 9 is 18. And then ln of 3 minus 1/4 This is like 1 over 4 times 9. 4 times 9 is 36. So minus 1 over 36. Okay, and then minus the rest of what we get when we plug in 1. If we're just so everything in here is negative, so when I subtract a bunch of negative things, it's gonna make everything positive. So this becomes 1 over 2 times 1 squared times ln of 1. That whole thing's actually gonna end up equaling 0, and then plus 1 over 4 times 1 squared, which is just 1 over 4. So this would be our final answer. You could just replace this with 0 if you want. I don't really care, but that's what it is.